Hey there, today we'll be doing this question 2316, count unreachable pairs of nodes in an undirected graph on Leetcode. The given question statement is you are given an integer n. There is an undirected graph with n nodes numbered from 0 to n minus 1. You are given a 2D integer array edges where edges of I is equals to a of I and b of I. Denotes that there exists an undirected graph which connecting nodes a of I and b of I return the number of pairs of different nodes that are unreachable from each other. So let's understand this question statement with this example to write here. So they have given these graphs. Okay, so the graphs can be disconnected also. That means if you see these graphs are connected, but there is no way that 3 can reach this or this, right? So this is what we mean by a disconnected graph. So they have also said the number of nodes will be from 0 to n minus 1. That is what we are having. Now if we see, we want to just find the number of pairs such that the nodes are unreachable. Now when are the nodes unreachable? Let's just take an example with 3 and 1 6. Let's just say we have a graph, this one right now. Let's just take this bracketed graph. Okay, 3 and 1 6. Now in this 1 6, 1 can reach 6, 6 can reach 1, right? Now this is perfectly fine, but 3 cannot reach 1, neither can it reach 6. Now this is where the problem gets interesting. And if you understand this part, it will be very easy for you to understand the whole thing apart from this one. Now for 1 6, we know the number of nodes are 2, right? In this graph, that is this connected graph, we have 1 to 6. And by connected graph I mean a graph which is reachable through any number of nodes. Okay, so this graph is a connected graph. Why? Because from 1 we can reach the other node, or from 6 we can reach the other node. Okay, so this is the meaning of a connected graph right here. Now we see in 3 there is only one node. Right now how many pairs can be formed from here? Now if you see, we have two nodes here. So this one, and we have one node. So we can form either this one, that is this guy will form a pair with this one, so one. Now or this node will form a pair with this one. So the number of pairs that we can form is 2. Okay, so how do we actually do this? Now there is a formula, simple math formula, that is, if we have, let's just say, 5 elements, 1 2 3, let's just take 3 elements for now. If we have 3 elements, the number of pairs that we can form is n into n minus 1 by 2, wherein n is the number of elements. So the number of elements that we have here is 3. So we'll just say 3 into 3 minus 1, that is 2. So we'll be able to form only 3 pairs, and if you just verify it, you will see that yes, it is indeed true. Now how will this formula actually help us to get the answer that is desired here? Now if we know that we have 0 to n minus 1 nodes, that is, if I have 0 1 2 3, let's just say these many nodes. Okay, so how many nodes are there in total? There are 4 nodes. So I know that in total I will have 4 into 4 minus 1, that is 3 by 2 number of pairs in total. Okay, so I will be having at total 6 pairs. Now if that is connecting or not connecting, that is a different story altogether. Okay, but first of all, we just need to take care, or we just need to find that how many in total pairs can we find. Now let's just take this example to write here. So here we are having how many nodes? If you see, we have 0 1 2 3 4 5 6. That is, in total we are having total of 7 nodes. Okay, numbered from 0 to 6. Now these 7 nodes, just forget about that they are connected or not connected. Okay, let's just say they are individual and they want to form a pair. It can do it, right? 7 into 7 minus 1 by, and this. So the number of total pairs it can form is 21 if there is, let's just say, no edges. Okay, let's just say there is no edges, that it is not connecting, and every node is in an individual basis. Okay, now if it were to be individual nodes, it could have formed 21 pairs. But there is a problem here. We see that some nodes are connected, that is, these things are connected right here. If these things are connected, what can we see? That we can see that 0 can reach this 2, this 4 and 5. So this pairs, that is these pairs, are not to be included my answer. So that is where this part comes into play. At first we'll be just finding out whatever is the total number of pairs we can find, and after that we'll be removing the number of connected components number and the pair it can form. That means this 0 2 4 and 5, there are how many total nodes? There are 4 nodes, and these nodes are connected by each other, right? These nodes are connected by each other. That means these guys can form a pair. Obviously not, because in the question they have said we need to find out the number of nodes that are unreachable. That means let's just say 0 to 3, because these are unreachable, but 0 to 2 and these things are all reachable, right? So we just need to find out the number of connected components. That means from these number of nodes we can reach all these nodes. And how many such nodes are there? There are 4 nodes of such kind, right? For this one, So four nodes of this are there. So how many pairs can this form if I were to be allowed to actually add that to my answer? So the number of nodes this actually is forming is this, that is 6. It is contributing 6 to my answer. But remember, we are only concerned about what? We are just concerned about the unreachable nodes, right? So in total, we had what? We had 21. Now you must be getting the hang of the answer. What we will be doing? Yes, we'll be just subtracting the connected components. That means I know these nodes are not to be included in my answer. So I know what is the total. I know what I don't want. So I can just subtract these from my answer and I'll get the answer. So from this, what was this contributing to my answer? It was contributing 6 to my answer. So I just remove those 6 nodes. Now these 1 and 6. So I see that 1 and 6 are connected. That means these two guys can obviously reach. What is it contributing to my answer? What is it contributing in my 21 thing? We'll just calculate that, and which will be nothing but the number of nodes, that is 2, n into n minus 1 by 2. So it is 1. So this graph is contributing 1 to my answer. So I'll again subtract 1 from here, right? Now, what is this single node contributing to my answer? It is contributing nothing. If you see, if you put on the formula, you'll get it. It will be nothing. You'll get 0, right? So this is what your answer stands out to be. All you need to do is you just find out whatever the total number of nodes is, which is already given in your question. That is, n is given already in your question. After that, you do a DFS. And how do you find this connected component? We just do a DFS starting from every node. Now, when I start a DFS from, let's just say 0, what will it do? It will visit this, this, and this. It cannot visit any other thing. It will give me the number of nodes from there. Yes, it will give us. So we will just subtract that. And the number of nodes that it has given us, we'll just subtract the number of pairs it was forming eventually from this. So we'll subtract this. Okay. Now, after this is done, now are we going to start the DFS from 2? Obviously not, because it has already been visited. We will never do that. Now we will come on to 1. 0 is done. Now come on to 1. 1 will say, okay, I just have one edge that is coming from me, that is 1 to 6. I'll also subtract what I am contributing to my answer. So we'll subtract this. So this is how we actually form the answer. So now let's just get to the code part and you'll understand it perfectly. So this is the code part. At first we have created an adjacency list, which is an undirected graph. Undirected graph means from both the edges we are able to reach. Okay, so this is an undirected graph. After that, what are we doing? We just created the visited array. And remember, we talked about DFS, right? So the only prerequisite to this question is you should know DFS, and that will be all for it. Okay. So DFS says, first of all, we go from 0 to n, that is the number of nodes. After that, we see that if the node has already not been visited, and if I have some adjacency, that means if it does have some edges, then only I'll go inside. And what am I going to do? I'm going to do a DFS. That means how many nodes are there that it is connecting. Let's just say I have something like this. 1 2 3, and there is another graph that is 4 and 5 is connected. So when I start from 1, I will say that 1 2 and 3 is connected. Okay, and let's just see the DFS code. It is a very basic DFS code that we write. Okay, so we just do this DFS, and what it is going to do, it is going to give us the number of elements or the number of nodes that are connected in this component right here. Fine. So this is what this DFS gives us. So if we see the DFS code, after the DFS code is completed, we'll get that is there is 3 elements in this connected component right now. Okay, now what are we going to do? We are just going to subtract whatever it is contributing to my answer. These 3 nodes were connected, right? So what is it contributing to my answer right now? That is n into n minus 1 by 2. That is, it is contributing 3 pairs, which I don't want. So at the end of the day, what are we going to do? We are going to subtract total minus whatever it was contributing, right? So I could have rushed the explanation part here on the DFS part. Let's just see the DFS part again if you have not understood it. So this is a very easy DFS code. Okay, this is standard one. At first, what do? We just see that if it is visited, we return. Otherwise, what do? We carry a number variable which will say that these many elements are there. And what do? We mark the visited element. After that, we just do a normal DFS right here for every element. Now, what is this subvariable? The subvariable says that these many elements are there as a connected component. So 1 2 3, let's just say this is a connected component. 4 and 5, it's a connected component right here. So after the DFS, I will get that 1 2 3 is there. It is forming a pair. It can form a pair as a connected component, and I do not want these because everything is reachable from here. So number of pairs that are unwanted from this is what? 3. How did we take it out? From the formula, right? Now I'm storing everything in a sub variable. Okay, and at the end of the day, what are we doing? We find out what is the total number of pairs we can find out, and what is the not needed part of the pairs that we can subtract from our answer. That is what we are doing here. We're just taking out the total number of pairs and we are just subtracting the unwanted pairs that we do not want. And the unwanted pairs are the ones which are totally reachable by one another. Okay, and at the end of the day we are just returning the answer. And if you do want the code, it will be linked in the description, and if you have any doubt you can still ask me in the comment as well. I'll be replying to that. And if you did understand the explanation, please